topic of this video is how to graph piecewise defined functions. A piecewise defined function is a function that has different rules on pieces of its domain, and we actually evaluated a piecewise defined function in the last section, but here we're going to actually get more into the graphing of it. So notice that it is a function, as we've discussed before, because the values of x that are stated here for these different pieces on the graph don't overlap, and so there's only going to be one output for every input of x. So the way that I suggest that you graph this particular type of function is that you think of it as however many pieces you have. In this case we have 3 pieces for 3 different parts of the domain. So one piece is y is equal to x plus 3. So we would want to graph that. Then our other piece is y is equal to 3. And then lastly we have y is equal to 2x minus 1. And what's very important here is that we have to specify or be very particular to stay within the stated piece of the domain that is specified here. So for the first piece we can only apply that rule for values that are x or less than or equal to 0. The second piece applies from 0 up to and including 2. And the last piece applies only when x is larger than 2. So the way that I do these by hand is I start by picking values of x that satisfy this criteria that's given. So x has to be less than or equal to 0. So we want to start with 0 as one input, and then we also need something less than that. So less than 0 would be like negative 1. And then when we plug it in, 0 plus 3 is simply 3. And then negative 1 plus 3 is 2. So on this particular piece of the graph we have the points 0, 3, which notice is included as part of that graph because we're allowed to include 0 there. So we have 0, 3, and then negative 1, 2. Now if you wanted more points less than 0, you could certainly include it. Like if I wanted to put in negative 3 plus 3 is 0, so that gives me another point there. So this piece is a piece of a line that is only defined for values that are less than or equal to 0. I can't extend it beyond 0 because that function rule does not apply there. Now between the 0 and the 2, my y value is simply 3. Now I'm going to kind of contradict what I just said. I said to include values of x that are in the specified domain. Well, I actually have to include the endpoints because notice that x is greater than 0. But numbers greater than 0 would be something like 0.01, 0.0005. There's no way that I can really get as close to 0 as I need to without actually finding the function value at 0. But now what's going to happen, since 0 is really not included as part of that piece, I'm going to use an open circle at that particular point. So when I plug in 0 to this rule, y is simply 3. Now I need something between 0 and 2, so we can use 1. And then my endpoint is 2. Oops, why did I put 2 there? I meant to say 3. Let me erase that there. Okay, so notice here I would have an open circle at 0, 3, but I've already got a closed circle there from the last piece. So an open circle on top of a closed circle just makes it closed. And then we have 1, 3, and 2, 3. So that's just a horizontal piece. Now I have to go to my third piece, and that's defined for values greater than 2. But again, I've got to include 2 because I've got things like, what, 2.01, 2.003, so I'm really close to 2, so I need to know what happens at 2, but we would have an open circle if needed. So if I plug in 2 into this function rule, 2 times 2 is 4, minus 1 is 3, and then larger than 2, let's say 3. So 2 times 3 is 6, minus 1 would be 5. And we know that is a line, so 2 points would be sufficient. So here I would have an open circle at the 2, 3 because it's not really including the 2 in the domain. But notice 2, 3 as an open circle would lie on top of that 2, 3 that's already closed from the last piece. So I'd have 2, 3 and then 3, 5. Okay. So that would be the graph of that piecewise defined function. So as a general rule, you're going to divide it up into the pieces that you need, choose values for x within the specified piece of the domain. You do need to evaluate the function at the endpoint. If you're allowed to include that, that is where it's equal to it, you want to have a closed circle at that point. If you're strictly less than or strictly greater than, you would have an open circle at that point. Okay, so let me know if you have questions on that particular topic.